We're going to start any second now, but Carol Botha is saying it's cloudy in South Africa, so Slooh is online, super excited. So we're going to kick off as soon as I'm told we are
And you
live.
are ready to roll.
Well, there you go. Oh, and there goes the clock as well. Perfect timing. Welcome to Slooh, where educators bring live astronomy like this into their classrooms to inspire and engage their students in the study of space, astronomy, and earth sciences. Got some good news about that. Students and members use Slooh's live telescopes in the Canary Islands, Chile, and our Australian observatories to capture images of celestial objects that they use in our unique curriculum aligned quest learning activities. And we've got a very special one here. So if you are a Slooh member, make sure, just like the studio is doing now, make sure you snap images. I would recommend using the Canary 2 ultra wide telescope. We'll go into those a little bit later. But anyway, so they use these telescopes to look up, but launching this fall, they'll also be able to peer back at Earth using orbiting satellites and our Earth science learning activities to study our home planet and expand that depth of their learning in geology, geography, environmental science, and space situational awareness. But tonight we're using our huge telescopes located at our observatories in the Canary Islands and in Chile to watch a triple lunar event. It's a harvest moon. It's the largest supermoon of 2024. And to cap it off, we have a partial lunar eclipse. We're going to talk about all of this in so much detail. I'm Paul Cox, your host this evening. And together with our expert and the special guests, we've got some really special guests tonight, I tell you. We'll be learning about all three of those phenomena. Now, let's take a quick look at what we're seeing on the screen. This is our Canary 1. This is a half-meter telescope. It's actually quite difficult to image the moon because it has so much light gathering capability that we have to do some special stuff. But we can already see here that we've got the moon partially in Earth's shadow. Now, it's a supermoon, so it appears big, which means it only just fits within the field of view of that. But this is our Canary 2 ultra wide field telescope, and we can see the eclipse starting there so well. This is the one that I would recommend that you snap images of for your Quest learning activities. And we're going to talk about that in a sec. Slooh members can snap images from all of the live feeds. Just go to the telescope page, which is this, and you just click that little camera button up there. The studio will do that for us. Click capture an image. There you go. Open up the image full size, and that is automatically saved for you for use in all of your Quest learning activities. And Slooh members do this every night to capture the moon, planet, stars, star clusters, galaxies, and nebulae, and a whole stack more besides. Now, you'll be able to use your images in our special Quest learning activity that we'll show you later. But just like all of our quests, you'll learn more about these three phenomena tonight and create a terrific infographic poster. We're going to see some good examples of that later as well to showcase your images. You can also create a time-lapse animation of the eclipse using our special Quest animation tool. And I'm really looking forward to seeing some of those. Now, before we invite our first guest, to join us to explain the basics of lunar eclipses, let's take a look at the timings of what we're going to see. What's called the penumbral eclipse started an hour and 20 minutes ago, something like that. And that can be difficult to see, although I did pop outside just before the star party started, and I could see it here from the UK. We've got a beautiful, clear night. I'm stuck on my screen here, but we've got these splendid views from the Canary Islands. The partial eclipse begins at 13 minutes past the hour. So that's in about 10 minutes time, about 9 minutes time. So keep your eyes out for Earth's shadow becoming a lot darker than we're actually seeing it there. And it's just going to be a little bit of a nibble out of the moon. Greatest eclipse happens at 44 minutes past the hour. So 35 minutes time, 40 minutes time. And the partial eclipse finishes in an hour's time, but we have live telescope views for students and members until the very end of the eclipse in just under 3 hours time, if I've got my timing right. Now, That's what we'll see. But what are we going to learn about and discuss with our special guest? Well, we're going to go back to basics with a Lunar Eclipse 101 with Slooh's Director of Curriculum, Dr. John Bovair. We've also got some very special guests from Purdue University's Physics and Astronomy Outreach program called SMAP, Dr. David Cederberg, with two of his students, Mariana and Matthew. And they're going to give us some presentations actually and share some of the stuff they've been doing on Slooh. So I'm really excited about that. Don't forget, Slooh members can join us in Zoom to ask questions throughout the event. So we'll keep an eye open in chat in the Zoom webinar there. So we've got plenty to look forward to. So let's get started and welcome my first guest, Dr. John Bovair. Good evening, John.
Good evening, Paul. How are you?
I'm very well indeed. How about this? It's
Uh,
not looking bad already, is it?
it's not. It's not. The moon hasn't risen here, so it's perfect that we have Slooh so that I can
Oh,
enjoy this with everyone. It's the views have been looking great
they
leading up
have.
to the start.
They have. So we are a dispersed team here at Slooh. I'm over here in the UK. John's over on the west coast of the USA, and headquarters is in Connecticut. But we've got loads of people joining us tonight because, of course, it's the beginning of the school year, isn't it, John? So we are seeing a
Yes.
whole new influx of students. And I'm just saying here that Agnes Connerty is saying, my two classes from Washington, D.C. are attending this star party. Hello, everybody in Washington, D.C. Agnes's students there. Good to meet John. We got these three big things happening tonight. Harvest Supermoon Eclipse. Let's start with the big one that we're seeing here about eclipses. What happens to the moon during a lunar eclipse?
But during a lunar eclipse, the moon passes into the Earth's shadow. And so tonight we're going to be seeing the moon mostly going into the penumbra, but there's also the umbra, which is the darker part of the shadow. It's just going to take a little nibble, like you said, out of the moon.
So the Earth's got two shadows? What's that about?
It does. It does. It has two shadows. It has the penumbra and the umbra. And it's the penumbra is basically the region where the Earth is only partially covering the sun. So if you think of like a big lamp and you only partially cover it, you don't get a full dark shadow. You get kind of a slightly shaded region. And so the umbra is the fully shaded inner region of the shadow, which is this dark region here. So there's actually a couple of different kinds of lunar eclipses. There's a total lunar eclipse, which is when the entirety of the moon goes into the umbra. There's a partial lunar eclipse which is what we're going to be experiencing tonight, where the moon is mostly going to be in the penumbral shadow, but it's going to pass just a little bit into the umbra. But then there are also penumbral lunar eclipses when the moon just goes into that slightly darkened part of the shadow and it doesn't go into the dark region at all.
So when we've got a total lunar eclipse, that's what we often call a blood moon because it actually changes color and it can look absolutely spectacular. Now, we've got grayscale images here, but with such a small partial eclipse, it's fairly unlikely we would have been able to see too much color anyway. But going back to that diagram, if an eclipse occurs when the Earth is between the moon and the sun, why don't we get an eclipse every month as the moon orbits Earth?
It's a really good question because especially if you look at any lunar phase diagram, like ones that you can make in our quest in Slooh's Quest learning
Yeah.
activities, it looks like we should be having eclipses every single month. However, the moon's orbit is actually tilted by 5 degrees compared to our orbital plane going around the sun. So what that basically means is that the shadow of the Earth is most likely is going to either pass below or above the full moon when it occurs. It's only going to be sometimes when everything lines up perfectly where the Earth's shadow actually hits the moon.
Okay, so I use some planetarium software, and a lot of students using Slooh use planetarium software as well. And I actually always have the Earth shadow projected onto my sky chart, and and you can see it. The moon's normally below it or above it, and it actually has the two shadows. It has the penumbral and the umbral. and you can see it just skimming in the Canary Islands tonight. But we mentioned, or I mentioned about the moon turning red.
Mhm.
Why does the moon turn red during a total lunar eclipse?
It's a really good question, and it's kind of puzzling at first, but just like when sunlight goes through the Earth's atmosphere and we're here on the surface, the atmosphere changes the directions, called scattering the directions that light moves. It's actually specifically called Rayleigh scattering. And what happens is the angle of deflection that light gets when it comes into the atmosphere is actually more deflected for blue light than it is compared to red light. And so what ends up happening is this is actually the reason why we have sunrises and sunsets that look so beautiful and red and oranges, because the scattering hasn't caused those colors to move away, but it caused all of the blues and the yellows to move in different directions. And that's actually why the sky is blue. So during a blood moon, the sunlight, like in this diagram here, comes towards the Earth, and it only goes through a thin bubble
Ah,
of the atmosphere, and all of the blue light is scattered off in different directions. And then the atmosphere kind of acts a little bit like a lens, and it focuses that red light towards the moon. Now, what I really like thinking about when I see a blood moon, and they say it's a blood moon, but it's not really that dark. I'd say it's more of a ruby moon, but that's a
hmm.
discussion for another day. The redness that we see on the moon is basically the light from all of the sunrises and sunsets that are occurring in the entire Earth during the eclipse.
I love
I think
that
that's
thought.
so cool.
That is such a cool just thing to think about, isn't it? Because if you were on the moon during a total lunar eclipse, you would see the Earth with this beautiful red ring around it because it's only the red light that's reaching you. Now, John, I we need to get onto this because hopefully
Oh, yes.
any students and members are snapping images. Studio is going to show us how to do that. Click that camera button. You can do it on any of the live telescope feeds. That's pretty cool. There's another image. Gretchen's capturing loads and loads of eclipse images tonight. So, John, I mentioned Quest learning activities at the outset. They're the cornerstone, aren't they, of our cosmic classroom, as we call it. Do we have any quests available that cover tonight's eclipse?
We do. We recently
Yay.
launched a Harvest Supermoon Eclipse 2024 quest where students can learn all about the lunar eclipses, harvest moons, and supermoons. And so definitely keep snapping images, like you were saying, because you can use up to 9 of those images to make a poster during the quest. And so let me just show you really quickly. All you need to do is click on quests and you'll find yourselves on the all quests category here. And there's a search bar. And if you can search for Harvest Supermoon Eclipse 2024, but if you just search for Harvest, you'll find it right away. And so this is the quest, and we can go ahead and just make sure you start the quest. Tonight would be best. Start it tomorrow. The quest isn't going to be on the platform forever. So if you want to do this quest, make sure you start it soon. And it's just a couple of steps where we learn all about, like I said, the harvest moon, partial lunar eclipse, the super moon, and we capture the moon here. And there's a second step that learns that students get to learn all about werewolves throughout history, going back from ancient times up until
Wow.
today, and actually werewolves in some other cultures around the world too, which is actually quite fascinating.
Brilliant. I love that. So although so all quests are available to all students and all members. So although they can start the quest tomorrow, they have to capture their images tonight, don't they? During
That's
this,
right.
yeah.
Yeah, that's totally right. You have to capture these images tonight. Tonight's the only time that the Harvest Supermoon eclipse is going to be occurring. And so an additional treat though is, even though I said that only that you can put up to 9 images on your quest posters for tonight, keep on snapping images throughout the entire eclipse, even after the show, because we have another quest called Slooh's Animation Quest, where you can take all of your images and turn it into a time-lapse animation of the entire eclipse.
I am so looking forward to seeing some of the time-lapse animations of this. So the animation tool, you capture all of your images, you load them into the tool, you align all of the images, and then this is going to look so spectacular seeing this actually quite intense shading now. Um, that's a pretty cool eclipse, isn't it, John?
Hey, this is a really cool eclipse. It's really unique. Every eclipse is unique in some way, but this one I think is a special one for sure.
It is.
And the quest
Harvest.
badge for this one, it's going to look like the Umbra, just lighten off the top part of the moon.
Oh, okay. John, you're going to be joining us a little bit later, aren't you? What are you going to be talking about a little bit later?
So a little bit later, I'm going to be talking about supermoons, and then I'm going to come back on and we're going to talk about harvest moons. Um, and then I'm going to be interviewed towards the
You're going to
end
be
of
interviewed.
tonight's star party. So excited for that.
I know that's going to be really cool. So, anybody out there, any students watching, if you want to be an astronomer, if you want to enter the space industry, it's part of our workforce development program. We've actually got a student who's been using Slooh going to interview John to find out how you do what John does. John, looking forward to seeing you a little bit later to give us a Supermoon 101. But for now, I am delighted to welcome an educator and two of his students who've been using Slooh over the last year or two. Dr. David Cederberg from the Purdue University and two of his students, Mariana and Matthew, who are members of the Purdue outreach program called SMAP. And we're going to learn what that stands for in a minute. Also going to talk to Dr. Cederberg and Matthew later, but I'd like to welcome Mariana to the Star Party. Hi, Mariana, can you hear me?
Hi, everyone.
Hi. So, uh, what can you tell us first of all about SMAP? What does it stand for, first of all, I guess?
So, SMAP means Saturday Morning Astrophysics at Purdue, and it is a really amazing program because we learn about space and the universe and all this stuff with experts on the topic. We do really cool experiments that everyone can easily do at home in a very fun and interactive way. So, uh, yeah, it's very fun. We learn a lot. And we also meet other people and space enthusiasts that help us grow our passion for astronomy.
Excellent.
This program, this program is for students of 8th grade to 12th grade. So it is really important because in these grades, we start considering and thinking about our career and our future. So growing our passion for astronomy, leveling up our skills is really important in this moment. So yeah, that's kind of a bit
Well,
about.
I think this is a great start, and you may have read some of the case studies actually on our website about some of the students who have been following programs like this, using Slooh, writing scientific papers at the age of 15, getting those published, and going off to all manner of wonderful, wonderful colleges and universities. But let me talk about Slooh. How long have you been using Slooh, Mariana?
About a year or two.
Okay. And have you got any kind of favorite activities or quests that you've done?
I did the Messier challenge. Uh,
Oh, that's one of my favorites. I mean, I have to say it's one of my favorites because I did write it. So what did you enjoy about this particular collection quest?
that it has a lot of objects to capture. So every day I would connect to Slooh and check the missions, schedule missions, and see how were the images going. And I had a lot of fun doing that, and seeing the final result was just very satisfying.
Have you printed this out at all? Is it printed out and stuck on a wall somewhere?
No, not yet.
Oh, you need to do that. And of course, you can always go back and you can edit it. And if you get a better image, you can always insert another one. But it already looks like you've got some absolutely fabulous images out. I can see the Lagoon Nebula up there. I can see the Andromeda Galaxy, the Triangulum Galaxy, the Pleiades. Wow, it is one of my favorite quests. And how long did it take you to finish this?
I believe like 3 months, 4 months.
Wow, that is pretty good going. You may be interested to know that I am currently working on a few other quests which are remarkably similar to that. So have a look for that. Let's have a quick look at the live telescope feeds, please. Let's keep an eye on the eclipse. Let's go over to the Canary 2 ultra wide field. What do you make of the eclipse so far, Mariana?
Sorry, can you repeat the question,
What
please?
do you make of the eclipse so far? It's looking pretty good, isn't it?
Oh yeah, it's an amazing view.
I'm
And
quite surprised actually that it's looking quite this dark on such a partial eclipse. Hmm? So,
yes,
anyway, I know you have prepared a few fun facts to share about the eclipse and supermoon, and you've got some slides as well. You've got the floor. Take it away. Tell us what you've been discovering.
okay, so as everyone knows, we're going to see the Harvest Supermoon Eclipse. And this is a very special event because it combines three phenomena: the harvest moon, the supermoon, and the partial lunar eclipse. So a harvest moon is the closest full moon to the autumn equinox, that will be the 22nd of September. And it is called the harvest moon because this moon gave farmers extra light to harvest their crops until late in the evening. The supermoon is when the moon is closer to the earth, so it appears bigger and brighter. You can see here in this image a comparison between a full moon and a supermoon, so we can see it is bigger. And the third phenomenon is the partial lunar eclipse, that it is when the part of the moon is covered by the Earth's shadow. So we have the sun, the Earth, and the moon, and a part of the moon is covered by the Earth's shadow.
I'm going to set you a challenge, Mariana. So tonight is a supermoon. All right. I want you to capture some images of that tonight. And with the same telescope later on in the year, or maybe early next year, capture the mini or micro moon and compare them. And you can make a great montage image with your Slooh images showing just how much bigger it is, because it does actually make quite a bit of difference. But carry on. This is great.
Um, can you please pass into the other slide? Thank you. So a supermoon happens 3 to 4 times a year. A harvest moon happens once a year, and lunar eclipses happen around 2 to 3 times a year. So we are very lucky today to have these three events combined at once.
Mm.
Supermoons can appear 14% bigger and 30% brighter. And here in this image, we can see a comparison between a perigee and an apogee. The perigee is when the moon is closer to the earth, and the apogee is when it is farther. So we can see there is a great difference in brightness
Mm.
and in the size. And the final fun fact is that the next lunar eclipse and supermoon will be on 9 years in
Wow.
October of 2033.
Well, I'm
So
glad we're capturing it tonight if it's going to be that long.
we should really enjoy it today.
Exactly. I can remember one that we did in, I think it was 2015 or 2016. And that was a supermoon as well. So you said there that there were 3 or 4 supermoons a year. One of the things I always think about, and I don't know what your opinion is on this, but if it's a supermoon, and if you have 3 or 4 of them all in a row, is it really that super? And that's why I think tonight is the really exciting one. And it's the one that we've chosen to cover because it is the largest supermoon of the year. What are your thoughts on that, Mariana?
I completely agree with you. I mean, it happens a lot of
Yeah,
times a year. So yeah, choosing this event was like a great idea because it is
exactly.
really special.
Maybe we should retitle the other supermoons kind of mild supermoon, kind of middling supermoon, the best supermoon, and then come up with some other names for some of those other ones.
Yeah, that's true.
Mariana, thank you so much for doing all of that and sharing that presentation. I hope we're going to see you back on another star party and see you in the Slooh community. And I'm looking forward to seeing your Quest poster as well, because that Messier challenge one was absolutely marvelous. So thank you very much for taking the time to do all of that for us.
Thank you to thank you to you for the opportunity for being
Uh,
here.
An
Thanks.
absolute pleasure. Now, we are going to talk to Dr. Cederberg later. And if, like Matthew, you're interested in forging a career in astronomy or the space industry, he's going to be talking to Dr. John Bovet a little later. So stay tuned for that. I'm not going to really be talking to Dr. John Bovet. He's going to be interviewing John. I know John's feeling a bit of pressure there, but talk the devil. I'd like to welcome John back to talk a little bit more about supermoons. Hey, John.
Hey there, Paul.
What did you think of Mariana's presentation?
Mariana did an absolutely fantastic presentation. In
That
fact, I
was
think
good.
her and I kind of co maybe mentally collaborated because a lot of the things that she was saying, I don't really have to say anymore. So, how about that?
Okay. Well, it might be brief then. We've got another 20 minutes before we're going to hit the maximum partial lunar eclipse. But you can see just how much, John, since we last spoke 10 minutes ago, look how much darker the moon is.
It is. It's incredibly darker. It just looks so awesome. I can't believe it. Oh, am I seeing part of the Umbra? I think you can. No,
Possibly can.
no, that can't be. Can it be? I don't know.
Uh, yeah,
So
it
this
could be.
bite right there.
It does look like a bit of a bite there, doesn't it? So it's going to change over the next 15-20 minutes. So keep an eye on that. Don't forget, everybody, keep snapping images from the telescope so that you can use them in your Quest learning activities to create your infographic poster and maybe a time-lapse animation. Now, as we go into talking about supermoons in more depth, can we just hop over to the Canary 1 telescope? Because I just want to have a look at something. Um, Now, this is, we don't normally use the Canary 1, this half-meter telescope for the moon, because frankly, the moon is too bright normally for this huge telescope. But when the moon is perfectly centered here, it is virtually on the edge of the image, John. And that's because it's a supermoon. It's a lot bigger than it normally is. So what is a supermoon and what makes it super?
Well, as Mariella perfectly pointed out, the supermoons are happening when the moon is close to us in its orbit near perigee. And this causes it to be bigger than it normally is, just as when anything gets a little closer to you, it looks a little bit bigger. It's interesting though, the term supermoon is not really a scientific term. It's one that the media and the public like using, but I like to think of it as being like the what you call it when the moon and when the full moon coincides with that closest point to us here.
Yeah. And a lot of astronomers over the years have been a little bit snobby about the term supermoon. But I have to say, I quite like it because it normally hits the news, local news and stuff like that. And it gets more people out staring up at the sky and taking an interest in the night sky and the moon. And anything that does that, frankly, to me, is a good thing, isn't it?
Oh, it absolutely is. It absolutely is. And it's such an important aspect too of understanding not only how the moon orbits, but just how everything else orbits. I mean, for such a long period of time, we thought that everything orbited like the moon, we thought that the moon orbited around the Earth in a perfect circle, which meant that the distance between us and the moon wouldn't change, which means that we shouldn't have supermoons or micromoons if the moon had a circular orbit, but it actually has an elliptical orbit, kind of like
Right.
what I'm showing here. So it is proof that you can say that the moon has an elliptical orbit. You can see it with your own eyes. You don't need history. You don't really need anything. Just Slooh and watching it.
Exactly. So the supermoon is when the moon is at what astronomers call perigee, right?
Right.
Yep.
That's right. And when the moon is near apogee, the furthest distance, we have a micromoon. And the
Micromoon or mini moon. Oh, this is
or
a
a
good
mini moon.
comparison, John. This is a good comparison.
It is, yeah. So this shows similar to what Mariana showed during her presentation. This is a comparison of mini moon and supermoon, and you can really see the difference between the two. It's quite remarkable. Even the brightness of the moon is different
Yeah. I
in
think
both
it's
of
the
these.
I think it's the brightness actually that people do notice. But of course, one of the issues is, and I've heard a lot of astronomers say this, that, oh, you can't tell the difference between a supermoon and a normal moon. Well, you can very easily in that comparison. But of course, when we're seeing the moon in the night sky, is it that easy to tell? I'm not sure myself whether or not it is. I'm not sure whether I could tell the difference.
Yeah, it's pretty difficult because what you need is just like on this image here, you need something to compare the moon to,
Yeah.
the size of the moon to. And when the moon is in the sky, there's really nothing to compare it to. I mean, that's why, when you catch the moon on the horizon, it looks like the moon is really big and it shrinks by the time it goes up, but really the moon's the same size all throughout that. So, I don't know, maybe one cool trick that you can do if you're outside looking at the moon, if you hold your pinky out full arm's length, then the width of your pinky is about a half of a degree, and that's the typical diameter of the moon on average. So maybe that could be a way that you could see for yourself that it's a supermoon.
This is a great shot, isn't it, John? This is the Canary 2 Wide Field Telescope. Once again, one that we don't usually use for the moon because, as you can see, the lower half there, it's too bright. But look at that. I mean, it goes into jet blackness now. So this is the moon descending into the penumbral and umbral shadow, just as John was describing earlier. So, supermoons, John, how frequent are they? And Mariana said we can get 3 to 4 a year. Is that right?
That's right. Yes, 3 to 4 a year. Now that's using a definition that a supermoon occurs when the moon is in a full moon phase and it's within 90 degrees of it, or 90% of its perigee. So it doesn't necessarily have to be right at perigee. It can be kind of
Mm.
near it to be considered a supermoon. But if you wanted to be a hardcore supermoon purist and say no, I want the moon to be right on perigee for it to be considered a supermoon, those occur about 1 to 2 times a year.
Okay.
Um, what's really neat, I found this graph that shows the full moons, which are the solid dots. It shows the new moons, which are the crosses, and this sort of sinusoid that you see here is the di distance between the moon and the Earth. And so you can see that sometimes the moon gets really close to us and it coincides with full moons, and those are our supermoons. But sometimes the moon, even though the moon will, what I'm trying to show here is the moon will always pass through perigee, but it will not always be a full moon when it passes through perigee. So those things have to
Got you.
coincide with one another. And so this one is the one that we're at for this month, and it is the closest one that we're going to have for the year. Pretty
That is
cool.
a brilliant graph. And one of the things I love about that is it just shows the clockwork nature of our solar system. I love that. It's almost metronomic, isn't it? So,
It is. I mean, you would think that, when you open up a textbook and you read about apogee and perigee, you read out a single number. But when you look at a graph like this, you can see that perigee and apogee actually change depending
yeah.
on where the rest of the planets are in the solar system. And so that's what makes supermoons like the ones we're having tonight super exciting.
And exactly, we can see that some supermoons are more super than others. So, and we can just see that one, can't we? Just dropping down. I love that graph, John. Is that in the Quest, by the way?
It's not in the Quest, so this is
Ooh.
a Star Party exclusive.
Okay, cool. Like it. There we go. Look, and the moon is plunging into Earth's shadow, getting really, really dark. Oh, I've just had a thought, John. I'm sitting here in my studio, of course, because we're doing the show. This is all happening outside, but you're going to be interviewed a little bit later, and I might disappear for 2 minutes, run outside, and go and check it out myself. But John, anything more on supermoons before we get you back to talk about Harvest Moon a little bit later?
No, I think that's it for the Supermoon 101. Make sure you check out the Quest though, and
Yeah,
for those listening, and see what other little tidbits I put in there about supermoons.
excellent. Yeah, there's some great information there. I stepped through the Quest today, John, so that's one of your best, I think. So, John, thank you very much for that Supermoon 101. We'll see you a bit later to discuss the Harvest Moon. Now then, we've already met one of his students, but now I would like to introduce Dr. David Cederberg and the University of Purdue SMAP program. Dave, can you hear me? Come in, Dave. Calling Dave. Hi.
I can hear you loud and clearly.
Great. Dave, you're there with Matthew. Matthew's going to interview Dr. John Bovair a little bit later on. But Mariana told us a little bit about the SMAP program. But this is, tell us what you do at Purdue University, because you said that you've got the best job in the world. I've always thought I've got the best job in the world, but you say you have. What is it that you get up to at Purdue University?
Well, I get challenged weekly, sometimes daily, by requests to do something I've never done before. So being asked to do something new. And so that's what really makes it challenging for me and enjoyable.
So tell us about the SMAP program. Mariana told us a little bit about it, but what is it that you get up to? What kind of activities do you do? Observing nights outside with telescopes, or is it all classroom and virtual based? What do you get up to?
Well, SMAP was one of those opportunities where a postdoc came to me about 7 years ago and said, what do you think about doing a program for middle and high school students, maybe monthly, and we do something related to astronomy? And I said, we've never done that before. Let's give it a try. And so we started SMAP back in about 2016, 2017. When COVID hit, with the constraints of the pandemic, we couldn't do it on campus in person anymore. And so we switched to a virtual format. And we continue to do it that way even through today. The challenge to that is to try and find engaging opportunities for lessons, for hands-on activities, and then find people to present them. And so my presenters are typically, I'm not an astronomer or astrophysicist myself. My presenters are faculty, grad students, and occasionally an undergrad. One of the really enjoyable parts of doing it remotely for me is to be able to offer it to students from around the world. So I had a child in Medellin, Colombia, asked me one time, do you think we could do SMAP in Colombia? And that was kind of the beginning of my challenge to do it worldwide. And I said, sure. And so in our first, about 3 years ago, Mariana was in fact part of that cohort among about 10 or 12 students from Colombia who join us every month. And so now I have a few students from Pakistan. I've had students from other countries, Canada, Argentina. And so that's brought a whole new dimension to what I do.
Brilliant. Brilliant. So I was going to ask you whether or not it's open to anybody to join. So if any students are out there and they'd be interested in joining the program, how do they go about that?
I can put the URL in the chat. In fact, I can do that right now, and they can check out the registration link and see what SMAP is all about. We also have a YouTube channel, And so we record every SMAP session,
Ah,
usually the third Saturday of the month, and those are available on the YouTube channel. We also have some lessons, activities, experiments available for teachers. I share a lot of what we do with other educators around the world.
great. We love that, because there's an awful lot of educators out there who actually get told you are teaching astronomy this semester, and they haven't got a science background necessarily, and certainly our platform aims to help them, but it sounds like you're doing the same kind of professional development there. So I talk about that. Purdue University themselves are using Slooh in some of their courses, but you're also using it as part of the SMAP program as well.
That's true. I'm really intrigued with the new quest that you are coming up with. I saw one just recently. Our last SMAP was about the Drake equation, the great filter. And if there are multiple life forms out there, why don't we find them? And if there are a few, why are there only a few? And you have a quest called Are We Alone? And I haven't done that one, but it looks very intriguing. A lot of what I do in SMAP, I find relative to many of the quests that you offer. And it makes a big parallel. Especially like the cultural and historical aspects. Clyde Tombaugh, for example, and other folks and cultures that you explore. Provide a fantastic opportunity.
And I always say to a lot of the educators that I talk to, they're often teaching quite a mixed cohort of students. A lot of them are not what you'd call natural STEM, or are not really interested in science and astronomy. So that's why those quests are there: culture, literature, historical, mythological, because they're little trigger points to get other people excited about astronomy. And that's what I always love about astronomy, and you must find that there are so many tentacles, so many perspectives, so many things that you can teach using astronomy as the baseline.
That's correct. The historical, cultural. So when students explore the quests, they're not only learning science, they're learning the people behind the science.
Yeah.
They're architecture and features on Earth and elsewhere. And I think that that cultural perspective adds a whole new dimension to astronomy.
It is. And you mentioned the Clyde Tombaugh quest, the discovery of Pluto. That was another one that I wrote, because John writes most of the quests, but it's one of the ones that I wrote because it's less scientific. And I love that history of astronomical discovery. You can see most of the books behind me. A lot of them are antique astronomy books. And that tells a story of how our understanding of the heavens have actually come about and changed and developed over the years. And that's a wonderful perspective as well to teach students. Dave, what advice would you give to any other educators who are looking maybe to deploy Slooh and get live astronomy into their classrooms?
Give it a try. I discovered Slooh about 2 years ago, and played around with it myself a little bit. And then we did a session in SMAP where we introduced students to the Slooh platform, and then gave them about 30 days to collect some images and create a quest that we suggested. And many of them went on to create multiple quests in that 30-day period. It really excited students to be able to, number one, get their own images, and then play with them by constructing their quests.
Well, we look forward to seeing more of your students and sharing maybe their quest posters and maybe their animations of tonight eclipse. So, Dave, it's wonderful to have you and your program part of the Slooh family. Thank you very much for joining us tonight. Thank you very much for getting Matthew and Mariana along. Matthew, we're going to be seeing you a little bit later. Well, I won't, but you're going to be interviewing Dr. John Bover. But Dave, for now, thank you very much for joining us.
Thank you, Paul, for the invitation.
Terrific. let's welcome Dr. John Bovair back, and we are going to talk reasonably briefly because we are at maximum eclipse right at this moment. John, can you hear me?
Yes, I can hear you.
Oh, this is looking pretty dark now, isn't it, eh? I mean, that's nearly half the moon has darkened, and I can't see the limb at all where it's in the partial phase. Can you?
I can just barely see the bite from the umbra shadow, which is showing the fact that the Earth is a sphere and it's not flat, which is one of the first, one
Yes.
of the early observations that humans did to realize that we were on a sphere instead of a flat Earth.
So flat earthers just need to go outside and take a look at the moon at the moment and maybe try and explain what they're seeing. Anyway, let's not go down that rabbit hole. John,
Definitely not.
it's the third element of tonight. We've got the supermoon, we've got a partial lunar eclipse, but it's also the harvest moon. Why do moons have different names like harvest moon, like strawberry moon? There's a whole stack of them.
There is. The different cultures worldwide have a tradition of naming the full moons based on the natural events and seasonal changes that are occurring around them. And so and this is important for helping them keep track of the yearly cycle, and to plan their actions accordingly based on the seasonal changes. We live in a very lucky time with all the technology where we have a calendar and we know what date it is, but it wasn't always the case. And so, um, most of the full moon names that we use in the United States are associated with Native Americans, colonial Americans, European sources. Um, so it's really interesting, really fun.
So what does the harvest moon represent then?
But just like what Mariana taught us earlier, the harvest moon is the moon that happens closest to the September equinox, and so this helps farmers go out at night and continue harvesting the crops because harvest moon let them know, since it's the closest moon to the September equinox, winter is coming, and so it's really important to start stockpiling all of the food for winter.
Okay.
And yeah.
So harvest moons don't always occur in September, do they? They can occur in October, is that right?
That's right. The harvest moon is an interesting one because typically the other full moon names are set for that particular month, but the
Mm,
harvest moon is the only one that kind of moves around between September and October, and it's because it's defined as being the full moon closest to the September equinox. And so for this year, the harvest moon is in September, and we don't have what's called a corn moon, which is the typical September name for a full moon. But next year, the October full moon is going to be closer to the September equinox. And so we won't have the hunter's moon next year.
okay. Oh, that's interesting. While you were talking about that, John, I just had a thought I hadn't had before. Well, I've covered so many harvest moons over the year. You're correctly saying, this is September equinox rather than fall equinox, because that's a very northern hemisphere centric thing. But do people in the southern hemisphere, maybe I know we've got some members from the southern hemisphere, both South Africa, Australia, and New Zealand watching the show tonight in the webinar. Can they tell us whether or not their harvest moon is in 6 months' time?
It's a
Never.
really it's a really good question because the whole point of the harvest moon is to stockpile for winter. So
Yeah,
yeah.
yeah.
So maybe
Okay.
using autumnal equinox is more appropriate than saying September equinox in this interesting instance.
Exactly. So thank you very much for that, John. Now, I'm actually going to dive out because we got a new presenter coming in. It's Matthew from SMAP. We're into workforce development. Loads of students that use Slooh want careers in astronomy or space industries, which are absolutely burgeoning. So, John, I think you're going to be interviewed by Matthew. I hope you get the job. while you're doing that, I'm going to nip outside. So as soon as Matthew comes on, he can take over from me and interview you. Good luck, John. Are you nervous?
Oh, definitely a little nervous before any interview. That keeps you on your
Matthew,
toes, though.
Matthew, welcome to the Star Party. Now, tell us before you start. This is an activity, isn't it, that you're charged to do to interview a professional somebody or other.
Yeah, it's actually for one of my engineering classes that I'm taking right now, Principles of Engineering. This is the first project he assigns us, and it's due at the end of the 9 weeks. And we have to go find someone to interview. And I immediately thought astrophysics, Slooh type stuff. And I contacted David, and he hooked me up with this. So it's really cool.
Very cool. Well, over to you. Be gentler with Dr. John Bovair. All right, but over to you.
All right. So I'm just going to start with some of the required questions. So please describe your STEM field, John.
So my STEM field is the S in STEM, specifically science, with a focus on astrophysics. And
Cool.
during my academic career, I researched exoplanets and the role of dark matter in galaxies. Yeah.
That's awesome. So what is your current job title here at Slooh?
At Slooh, I'm the director of curriculum.
So you design the quests and stuff mostly and
That's a
stuff.
big part of my role, yes. Anything related to the quest, the um, designing the quests, writing quests, reviewing quests, maintaining quests.
So then how did you first get involved with Slooh? Somebody reach out or?
I joined Slooh shortly after earning my PhD. At first, I actually worked for Slooh as an independent contractor, writing quest learning activities. And after writing quests for about 6 months, I was offered a full-time position, and I've been here ever since. Almost, is that true? 4 years now? Amazing. Yeah.
So we've already heard about writing the quest, right? So please describe some of your other particular job and duties that you have there.
Yeah, definitely. So as director of curriculum, as I mentioned, I oversee all the aspects of Slooh's Quest curriculum. My responsibilities include designing new quests, aligning them with curricular standards, reviewing and maintaining quests, authoring quests myself. For example, the Moments quest that ties to tonight's Star Party, and the Are We Alone quest that Dr. Cedarberg mentioned earlier in his segment. Beyond writing, I also create graphics and videos for Quest, those that are embedded in the Quest. I design poster templates that students use to design the posters, and I also design the Quest badges as well. I also conduct research to support the Quest development. I collaborate with Slooh's engineering team to integrate new features into the app, and I occasionally train new educators on how to use the platform. I also present about Slooh to conferences, workshops, meetings, both in the US and abroad to showcase Slooh's latest developments.
Interesting. So now, bit of an odd one. What does your average work schedule look like?
It's a good one. So I typically work Monday through Friday, 8 a.m. to 5 p.m. Although that can change when there's awesome events like tonight's Star Party, or any other special events that are happening.
Yeah, like when you reach out to people about Slooh and stuff. I mean,
Yeah. Sometimes depending on time zones, depending on where things are, I might have to jump on a call with some folks that may be outside of the work hours, but typically that's my work schedule.
all right. Really intrigued for your answers to some of these next questions. Really excited about these. If you had to, no. Starting with high school, describe your educational background chronologically.
Okay. Starting with high school, I attended a magnet high school that specialized in aviation and medicine because I aspired to become an astronaut at that time in my life. I could have earned my private pilot license, but I did shift my focus from aviation piloting to aerospace engineering due to my color blindness, which prevents me from pursuing a career as a pilot. But one of the most impactful experiences that I had in high school was taking AP Calculus BC, which covers college level calculus 1 and 2. It was instrumental for my understanding of science, especially physics. I realized pretty early on that calculus was essential for connecting different and understanding different science concepts. In fact, I used what I learned in calculus to help me through my physics class in high school. Um, then once I got to college, I initially majored in mechanical engineering, but later switched to physics after discovering my passion for exploring the cosmos. I took introductory astronomy classes as my elective classes, and those helped spark my interest in how physics can explain the workings of the universe. And this led me to actually change my major from mechanical engineering to physics and embark on a journey to understand how the universe works on a more fundamental level. The concept that the laws of physics apply universally, which is known as the Copernican principle, became sort of a guiding philosophy for my journey through my various curriculum. During undergrad, too, I worked in a geophysics research group, and this is something that you can do when you get to college, too. Ask any professor that's over there that's doing some sort of research. They may have a spot for you to jump in and start learning some things. And this was my first real experience doing scientific research. I traveled to Brookhaven National Laboratory in Long Island, New York, to do high pressure, high temperature experiments using the National Synchrotron Light Source. But later, I transitioned to doing astrophysics, studying dark matter and dwarf galaxies, and which is where I stayed for my master's degree in physics. These hands-on research gave me a strong foundation for academic writing, data analysis, and coding, which are skills that I continue to develop throughout my master's degree and then eventually into my PhD program. When I got to the PhD, I actually pivoted to studying exoplanets. My research focused on discovering missed planets in the published data using radio velocity techniques. I developed an analysis pipeline that found more than a dozen planetary systems that might have an additional planet. And this project allowed me to develop advanced statistical models and deepen my expertise in computer science and data analysis. So, for example, I actually adjusted my analysis pipeline to start analyzing geophysics data, which actually eventually went on to discover a new phase transition in water ice, which is pretty neat. But in graduate school, that's where I developed my love of teaching. This love was a big motivation for me to start working for Slooh. I taught astronomy labs as a graduate student, and after earning my PhD, I taught physics and astronomy at multiple institutions as an adjunct professor. Working for Slooh and being in charge of quests allows me to fuel my passion for astronomy or passion for teaching, but not only for just astronomy and physics, but also for math, mythology, social studies, and history. The last thing I want to point out is that it is definitely possible for somebody to earn a PhD and find jobs outside of academia like I have. If you end up spending the amount of years and time earning these degrees, don't feel like you have to stay in research academia. You have skills to solve problems, real world problems, in other areas.
All right, so obviously that's quite the long story there, education. So if you had to do it over related to your career or education, would you do anything differently?
Believe it or not, you asked me for 20 years worth of my life, so that's why I was a little bit long. But there is a lesson that I learned here that I think is incredibly important. I would make sure to focus more on networking. Networking is crucial in in really in all aspects of life, but especially in the scientific fields and space. space studies because it's crucial to build a strong network of connections because that's how you find various opportunities. You can be incredibly smart, but without a network, it's much harder to be noticed by potential employers. So I advise anybody that gets involved in astronomy or in space industries, attend events, cultivate relationships with your professors, your peers, and industry professionals that come on and talk to you, that may come on and talk to you, give presentations.
Good advice. I think probably I'll use that actually.
Great.
What was it that first got you interested in astronomy?
My fascination with astronomy started at a very young age. My parents played a big role in fostering that interest. I grew up watching a lot of space-themed shows from Star Wars, Stargate SG-1, Apollo 13, even various songs on Sesame Street when I was really young, like Ernie's song about living on the moon, just sparked my curiosity. And so, whenever there was a solar eclipse or a lunar eclipse that was visible from my location, my parents would set up pinhole projectors or sit outside with me to watch the event together. My mom decorated my room with glow-in-the-dark stars, and she even took the time to map out the different constellations on my ceiling. My dad bought us a telescope, which became one of my favorite gifts. And along with my love of science fiction, I was deeply inspired by various shows like Bill Nye the Science Guy and The Magic School Bus. So all of these things kind of helped to build my foundation and love for space and astronomy, kind of brick by brick.
Okay. My last question here, my favorite question. What advice would you give me as someone interested in pursuing a career path in astronomy or astrophysics? Such as your career. Like, what advice would you give me?
So my advice to you is to keep your passion for astronomy alive by staying engaged and sharing your interest with your family, your friends, and your peers. Stay updated with the latest discoveries. Get excited for things that are about to come on the along the horizon. And academically, I'd focus on math and computer science in addition to your science courses. Computer coding is essential for the field of astronomy because it allows you to handle and work with large amount of data and calculations that are involved in research. And there's so much data that you have to get through and so much math that you have to do that you can't do it by hand. You need to use computers to help you with it. But as I mentioned earlier, most importantly, I would focus on networking. Building relationships with your professors, your classmates, industry professionals is key to finding opportunities. The space science and space industry fields are full of exciting career paths, and networking can open doors that you never anticipated.
Okay, thank you. That's all I have for you. Um,
Ah,
Enjoyed hearing about that.
you're
Thank you,
welcome.
Matthew.
Thank you.
I've just learned loads more about. I've been working with John for years, but I've just learned loads more about him that I didn't know about. John, you've already got the job. I suspect I'm going to be out of a job because I reckon Matthew nailed it there, didn't he?
He really did. That was great.
So, John, did you enjoy being grilled there?
It was nice. It was a nice moment of reflecting back on where I started from and where I'm at now. And it's pretty great,
Now,
actually.
there's some great advice you gave there to all students. Hey, listen, just hopping back to our Harvest Supermoon Eclipse tonight, we were talking about when is the harvest moon down in the southern hemisphere, and we've got it's in 6 months' time in South America, and Carol Botha has said, down in South Africa, Harvest Moon is in March, and a few years ago she took part in a project to rename their full moons. And tonight for them is Spring Moon, which is quite cool. So
Oh, that's awesome.
we definitely need a quest, don't we, of the named moons. Have you got anything planned for that, John?
It is something that we've been tinkering around with is the idea of doing quests about different full moon names. And so definitely if there's a list of names for full moons down in South Africa, definitely send it along to us because that might
Yeah.
find its way into a quest.
And I'd love to see a mini moon supermoon quest as well, to be able to compare the images like that. John, right at the outset, I announced our excitement of launching our new Earth Science program. You've actually developed some sample quests for this, haven't you?
Yes, these are some open-ended quests that we're planning on releasing at some point after the new satellite feeds are available. And they're going to be doing kind of a lot of different things. We have some collection quests already that will have students capture different geological features in the US. We have quests that are about situational awareness, which are like the artificial satellites quest. But there's gonna be some other really cool ones, like the natural disasters one. I mean, we always hear things about different hurricanes or wildfires. Well, this is going to be a quest that will allow you to actually capture those things, animate them, just like you'll be able to animate the eclipse tonight, um, and learn more about it. And these are just going to be a lot of fun.
I love the idea that for so many years, students have been using Slooh's telescopes to peer into the universe, but now they're going to get the opportunity of peering back down at Earth with orbiting satellites. I think these are going to be really, really exciting. So we're
It
looking at a launch sometime in fall, aren't we, for some of these?
Launch for fall for the satellite images, satellite pages, and potentially some of these quests as well.
Excellent. John, thank you very much. Fountain of information as normal is. Thank you very much for joining us this evening.
Thank you so much, Paul. Thank you for having me.
Well, here we can see the eclipse is well underway. I did jump out into my back garden during the first bit of John's interview to be met with fairly typical English weather. It was clear earlier, but it's clouded over. But there was one little break in the cloud while I was standing there for a minute, and the moon looked like a quarter moon. It was cut in half. So if you get the opportunity, you can see this is our live feed from the Canary Islands. We haven't said this, I don't think, but a lunar eclipse is slightly different to a solar eclipse. While it's happening, if you can see the moon, everybody sees it wherever you are. So if you get the opportunity in a couple of minutes' time when we finish the show, that you can still go out. But after the show, we have still got live images on Slooh, and you can carry on snapping images for your quest. But it's time to end the star party. I'd like to thank our special guest, Dr. John Bovair, Dr. Cederberg from Purdue University, and huge thanks to our student guests tonight, Mariana and Matthew. They were brilliant presentation by Mariana and great interview by Matthew. So thank you very much for doing that. Now, we got loads coming up at Slooh over the coming months. Watch out for those announcements on our new science program and the Gravity Awards that are going to showcase and reward students' work using Slooh's unique educational platform. So that's going to be really good. You can already get underway with that. You can just share an observation, and the most popular ones will automatically be entered into the Gravity Awards. And keep your eyes out for our coverage of the Blaze star. This is a star system forecast to go boom over the next couple of weeks. Students have already been monitoring this star system every night to gather their images for our special quest, where students are going to track the star as it goes nova in a colossal cosmic explosion. So if you haven't done so already, start the quest now to learn about this fascinating and rare event. We're also partnering with the Jet Propulsion Laboratory to provide live images of Jupiter for their pre-launch party of the Europa Clipper mission, and that's on October 9th. The launch is due to occur on October 10th. It may change a little bit. We've also got, we'll have special guests on that from JPL who are going to share their story of this remarkable mission, and tell students some of the amazing jobs that are available in the space industry and how to get there. But that's it for now for our Harvest Supermoon Eclipse Star Party. Until next time, clear skies, everyone.